Okay, so here we want to show that this series is decreasing. We can't really do this one with doing the idea of a sub n plus 1 is less than a sub n. I don't really know how to build this and say it with any confidence that this is true. Okay, so don't try to do this with any function, usually with something wonky like this. So we're going to have to use the first derivative test. So I'm just going to take the derivative. Excuse me. First, I'm going to rewrite my function as a function of x, which is the ln of x over x. Please make sure whenever you're checking for increasing or decreasing and you're going to take the derivative, that you change all your n's to x's. I take the derivative. I use a little quotient rule here. The derivative of natural log of x is 1 over x times x minus the natural log of x times this thing, which is just 1 all over x squared. I get f prime of x is equal to 1 minus the natural log of x all over x squared. My denominator equals 0 and x equals 0. So that would be f prime of 0 does not exist. It's just a critical number. And we want to make sure that we're aware of that. That we'll address it later if we need to. And if I set my numerator equal to 0, I get 1 minus the ln of x. ln of x is 1. X equals e. Okay. So I'm going to slide over here now. I'm just going to draw a little quick number line here. Here is 0. Here is 1, which is what my sigma starts at. And here is e, because e is 2.78 something. So I'm going to check a number to the right of e, because that's really because I'm going out towards infinity here. So as long as I can show that this thing's decreasing most of the time, I'm in pretty good shape. So if I do f prime, I'm going to choose 3 over here, f prime of 3. If I plug in 3 here, I get 1 minus the ln of 3 all over 3 squared. Hopefully everybody's okay that the ln of e, right, the ln of e is going to be 1. So the ln of 3 is going to be a little bit bigger than 1, right? So this is going to be 1 minus some number bigger than 1. This is going to be negative. So my series is decreasing to the right of e, right? So f prime of x is less than 0. Oh, look at that. My series starts at 1. How am I going to adjust for that? Well, let's just plug in 1 here. If I plug in 1, I get the ln of 1 over 1. And if I just rewrite my series, oh, sorry. Ln of 1, and then 2 is some number here, right? So this is the ln of 2 over 2. And then if I just start my series at 3, n equals 3, n equals 3 to infinity, the ln of n over n. Hopefully everybody's okay. The ln of 1 is 0, so that term just goes away. I get the ln of 2 plus over 2 plus n equals 3 to infinity, the ln of n over n. Well, my series is decreasing for every n beyond 3. Really, it was beyond e, but we only do integer values here. So that's why I'm saying it's decreasing beyond 3. If I just add one little small number, ln of 2 over 2, which is not going to be that big, it's not going to change the fact that this thing is decreasing and on so much more of the series. So you just need to make an adjustment if this was the case, that the series wasn't decreasing for all and that you were given. You can just peel off a couple terms and it doesn't change the fact that the series is going to be decreasing for just about an infinite number of terms with one less term, which doesn't really affect anything.